Hello, my name is Flex. Today I'm going to talk about the fuel cell. First, I'm going to define the fuel cell. Okay, a fuel cell is an electrochemical cell that converts the chemical energy of a fuel and an oxidizing agent into electricity through a pair of redox reactions. And fuel cells can produce electricity continuously as long as fuel and oxygen are supplied. Okay, there is two types of fuel cell. It is proton exchange membrane fuel cell and solid oxide fuel cell. Okay, proton exchange membrane fuel cells are an exciting clean energy technology for power delivery for a range of devices from automotive application to portable digital equipment. Okay, this is the block diagram for proton exchange membrane fuel cell. And solid oxide fuel cell is an energy conversion device that produces electricity by electrochemically combining a fuel and an oxidant across an ionic conducting oxide electrolyte. So this is the block diagram for solid oxide fuel cell.
Hello, my name is Kevin. Today I'm going to talk about proton exchange membrane fuel cell in more detail. I'm going to explain about how proton exchange membrane fuel cells work. Operation principle: polymer electrolyte membrane fuel cells, also referred to as proton exchange membrane fuel cells, utilize polymer electrolyte membranes such as Nafion to conduct protons for ion exchange purposes. PEMFC consume mainly hydrogen, methanol, or formic acid. During operation, the hydrogen, methanol, or formic acid in the anode chamber is oxidized, while the oxygen in the cathode chamber is reduced. This is the example of application for PEMC fuel cells. The Horizon H30 PEM fuel cell is a 30-watt air-fed or air-cooled self-humidified hydrogen fuel cell suitable for many small projects and uses. Because the fuel cell is air-cooled, there is not need for large, complicated, and expensive water cooling systems. Horizon H-series PEM fuel cells are semi-integrated, efficient, reliable systems that minimize the use of peripherals. As such, they are the most compact and lightweight fuel cells around the world. For this session, we are going to discuss the challenge for PEMC fuel cells. Proton exchange membrane fuel cells have received attention owing to their low operating temperature and quick startup. Fuel cells have high material cost, low power density, and short lifetime, which are major barriers to their use. In order to become commercially viable, PEMFC bipolar plates must be cheaper, lighter, and more compact. That's all for this session. Thank you.
Hello, my name is Paulus Yanting. Today I'm going to explain about application of fuel cell system. For the first point of the application of fuel cell system is to apply fuel cell in the remote traffic light. For the first point is apply fuel cell in remote traffic light. It is to backup power system, provide power when the primary power source is disrupted. Fuel cells used for backup remote traffic light when there does not have energy or electric. For the second point is apply fuel cell in fuel cell car. The second point is apply fuel cell in fuel cell car. For the car or another vehicle, especially for buses, the buses have successfully demonstrated the use of fuel for transportation purpose in the commercial vehicle market.
Hello, my name is Eteridan Sanai. I am going to talk about characteristic curve of a fuel cell. The characteristic curve is affected by the material used for the electrode. the internal resistance, the temperature, and the volume of hydrogen and oxygen being supplied. Secondly, I'm going to talk about describe a fuel cell electricity generation. A fuel cell is an electrochemical cell that converts the chemical energy of a fuel and oxidizing agent into electricity through a pair of redox reactions. Thirdly, I'm going to explain about determine the parameter that influence the characteristic curve. The knowledge of a saturated soil is indispensable for several hydrological and environmental problems such as permeation of water through reduction, groundwater recharge.
Hi, my name is Kurmalis Rajan, and I'm gonna explain the advantages and disadvantages of fuel cell technologies.
The advantages of fuel cell technologies is high efficiency conversion, high power density, and quiet operation. The only disadvantages of fuel cell associated with the cost. The two basic reasons are high cost compared to the other energy system technologies and operation require reliable fuel.
I will compare fuel cell technology in terms of electrolyte, temperature, system output, efficiency, application, and advantage.
Electrolyte. The main electrolyte types are alkali, monte, carbonate, piezophoric acid, proton exchange membrane, PEM, and solid oxide. Temperature. The operating temperature range is generally 160 until 220 Celsius.
This is the output system.
Efficiency. According to the U.S. Department of Energy, fuel cells are generally between 40 until 60% energy efficient. Application. Fuel cells can be used for portable, backup, transportation, and stationary power applications.
Hello, my name is Erickson Wan, and today I will going to explain about understand solid oxide fuel cell. Firstly, I'm going to explain how solid oxide fuel cell work.
A solid oxide fuel cell, or known as SOFC, is an electrochemical conversion device that produces electricity directly from oxidizing a fuel.
And secondly, I'm going to compare types of solid oxide fuel cell, which is the first one is energy tubular SOFC technology, and the second one is SOFC gas turbine hybrid.
The solid oxide fuel cell is a simple electrochemical device that operates at 1000 Celsius and is capable converting the chemical energy in natural gas fuel to AC electric power at approximately 45 efficiency when operating in a system at atmospheric pressure. Since the SOFC exhaust gas has a temperature of approximately 850 Celsius, the SOFC generator can be synergistically integrated with a gas turbine or GT, a generator by subletting the turbine, combustor, and pressurizing the SOFC, thereby enabling the generation of electricity at efficiencies approaching 60% or more.